Finally, parallel virtual machines. So now we talked about dividing one computer into many computers, but it is also possible to combine many computers into one computer. Alright? So PVM, parallel virtual machine, is the name of a open source software that allows running program in parallel on multiple machines. So it makes 1 out of n. And the grid computing and cluster computing are very similar idea. We'll talk more detail later on, but grid computing is that basically you want to run on many machines at the same time. Cluster computing is similar idea. And finally, the word para-virtualization, which is different from parallel virtual machines, right? Para-virtualization means that the hypervisor offers special APIs for operations that are difficult to run in a virtual environment. So it offers special APIs, and that's the thing, is that if you want to use those APIs, you have to change your operating system. You have to make your operating system, the guest operating system, to use those features. So you cannot take a vanilla Windows and run on use para-virtualization, because that hypervisor features it may not use. But if you change your Windows, which most people will not, probably they will go for Linux or something. If you change your Linux to use those features, then your virtual machine will run much faster. So requires modifying the guest OS, requires the source code for the guest OS, and so you change the code and you recompile it for the hypervisor. So for example, there are something for the code in the Linux which provides interface for many hypervisor and guest kernels. Okay? So now we have learned 4 different concepts. Let's just remember that we remember those 4 concepts. Hardware emulation simply means that you want to somehow be able to get instructions which are for a different processor on this, like so x86 on Spark or Spark on x86. That is emulation. Hardware assisted virtualization. That means that the hardware has some features which are designed for virtualization, which improves the speed. Parallel virtual machines simply means that you are using n machines to look like one. And para-virtualization is simply that the hypervisor gives you some help if you can use it. All right? So that finishes the discussion on concepts. Now, there are some products that you really need to know. I mean, if you say, I know about virtualization, but you have never heard of these things, then it looks not bad. So I have just gone a little bit out of the way and put some product names here that at least you need to know the names, and when you need to know more about it, you can read the book about them or read the Wikipedia or whatnot. I don't expect you to be reading Wikipedia about each of these, but you should just know the name. So Microsoft Virtual PC, I suppose everybody has used it, right? That is for free, and every laptop comes with it. I mean, Windows laptop. And I suppose it also is available for Mac. So most people are familiar with it. Zen is the next one. Zen is a popular open source hypervisor from Cambridge University. But now it is used in the products all the time. So it is endorsed by many manufacturers, and it is actually Citrix basically provides the support for it. Just like Red Hat Unix, you have Citrix Zen. Oracle VM VirtualBox. So this is another one. Now you will notice that all of these are free. Virtual PC is free, Zen is free, Oracle is free, VirtualBox is free. So VirtualBox runs on Linux, OS or Windows and almost every operating system, and then allows you to run virtual machines. Hyper-V is not free, but Microsoft Hyper-V is part of Windows 2008 plus servers, and there it allows you a lot of virtual things. Linux KVM also is free, and as you see the name, it virtual machine, basically it kernel virtual machine. It uses all these instructions, and then user mode Linux is an executable kernel and a root file system to create a virtual machine. So anyways, these are some of the very well-known ones, and you should just know the name and a little bit who makes it, things like that, so that you feel that you have heard these words. But then there comes a big company called VMware, whose sole business is virtualization, and it started the whole thing in some sense. And therefore, you cannot know about virtualization and not know VMware. It's like if you know computers and don't know Microsoft, and people say, what do you know? Right? So VMware is the father of virtualization, and we need to know what they sell. So there, one product is called ESX, which is a bare metal hypervisor, ESX. And so basically, this is what is used in the data centers, ESX. They have another thing. Before I go to vMotion feature, actually, that I have a whole slide on that, so I will just basically say that they have been, just like Google, they have been inventing new features in virtualization every year. So one of the features they have is vMotion, which allow you to move VMs very fast while running. So you don't have to stop a machine and go to the other machine, go to the physical machine. You can have a web server running here, and serving the web, you move it to some other place. All right? So that is the kind of thing they have, vMotion. ESXi is a smaller footprint version of ESX, but it's free. See, the hypervisors are all free. Let me say, no, not all free, but mostly free. All right? Many features require vCenter license, but the reason it is free is that if you really want to use those in any number more than 1 or 2, you need automation, and that automation is charged. All right? If you just want one ESXi, you can put it on your computer and you're all set, done. But if you want it in data center, you need 100 of them. You need a license for vCenter, which is the management tool. So vCenter allows managing multiple servers, and vMotion and storage vMotion and all that. So that is not free. ThinApp is one which is used for basically portable application creator. So you can take any application, or actually some applications, most applications, and use ThinApp, and it will create a version that is portable. You can run on, it doesn't need it doesn't create any registry keys. It just makes its own environment in which it can run from USB keys, right? Some of you have seen portable software, right? Which runs from USB keys, and that is ThinApp. Then there is a product called View, VMware View, which allows thin client. Basically, we talk about thin clients, right? So that you can use with multiple clients on a remote server. That is a View. Fusion is for Macs. So you can run Windows, Linux, anything on the OS X. They have something called VMware Workstation, which is basically for workstation environment. The ESX was for the data center environment. Then they have something called Player, which is a freeware version of VMware Workstation with limited functionalities. I forgot the word functionality there, features. And then they have something called High Availability, which makes sure that your VMs don't, you don't lose information when the physical server crashes. So they keep backup. Then there is a file system called VMFS. So this is a special file system for ESX cluster. What is a cluster? Basically what you do is you take a number of physical servers, and you say, well, maybe a rack, and say this is my one cluster. And then the VMs, generally they will share some resources, maybe storage and things like that. So that is what it is. It is file system for the cluster. So file system for VMs. That brings us to a whole new topic. Before I go to this new topic, any question about the products? I know all we did was remember the name, but it is important, because if you know virtualization and you don't know ESX, it feels like you don't know anything. So you have to know what is ESX, what is vMotion, what is vCenter, and every I would say white paper, not really the paper. Every white paper on virtualization will start with VMware. Even the competition start with VMware, because VMware is the one who invents these things. And then, so for example, this year they brought up virtual networking, and people are following that and all that. So that is important. Okay. All right. File systems for VMs. So using VMware's example, all physical disks are clustered into pools. So you have disks and you have computers, you have processors. So you put a group of processors and you put a group of disks and they all work together so that anybody can use any disk. So all physical disks are clustered into pools. Each VM has a virtual disk in some pool with extension .vmdk. How many have known the extension .bhd? Anybody knows BHD? Virtual hard disk. That is what you do with Microsoft PC. If you have any Microsoft virtual PC, your disk is BHD. In this case, it is .vmdk. It's a file with that extension. And the disk is formatted using the system, virtual machine file system, which is like NTFS. It's called VMFS, virtual machine file system. It's thin provisioning. Thin provisioning means the disk does not really take the space. So you can create a 100 gigabyte disk, but have only 1 gigabyte. Because the disk size is not required right at the beginning. If you start using 100 gigabyte, you will need 100 gigabyte. But as long as you don't use it, it's very small. As you keep using it, the size increases. So it has the size is dynamic. Okay, so that is called thin provisioning. Thick provisioning means static, means full size is allocated at creation. So you could have thin provisioning or thick provisioning. Thick provisioning means that you could, if you say create a 100 gigabyte disk, how much will you need at the beginning? 100 gigabyte, complete. Same thing is in BHD. When you create a virtual hard disk in Microsoft PC, it asks you whether you want to do, one way or the other. I don't remember the names they use, but you have the option of expandable disk or non-expandable disk. Right? Expandable disk will basically expand as the need grows. Then linked clone, and you could have something where you really don't need your own disk. You could be sharing the disk with somebody else. How do you share? Because we are all reading from it and we are not writing to it, so we can all read the same book. As long as you don't make any marks, nobody is unhappy. Right? So that's what it is that if there's a read-only information, say for example operating system disk, why do you want to make 2 copies? Everybody can read from the same disk. Non-linked disk is separate disk for each VM and it is writable, and that would be for VM specific data. If there is something specifically you want to take a note of, you put into your own disk. And persistent or non-persistent. So you could have a disk which is deleted as soon as the VM is released, or you could have a disk which is saved when the VM is released. Why? Because you want to come back up from the previous state, not from the fresh state. Right? Everything makes sense? All these concepts? All right. So this is what VMware does, and obviously that means everybody does in the industry now. And so the industry really needed a standard format for disks because VMware uses VMDK, Microsoft uses VHD, and XYZ uses something else. So they said, look, I cannot really move my VMs from my hypervisor to your hypervisor because you are using different format, right? So to make it one, now there is an industry standard format called OVF, Open Virtualization Format. So basically, if you use OVF disk or a disk in OVF format, then you can give it to anybody and they can run it on any hypervisor. Hopefully, let me qualify any hypervisor. Most hypervisors today support OVF. So that makes it a really portable disk. And so it is independent of hypervisor or processor architecture. OVF is the standard set by this organization. It is called DTMF, Distributed Management Task Force. And now it is an ISO IEC standards. ISO is the International Standards Organization. Right? So it is basically worldwide standard. IEC is the International Electrotechnical Commission. So basically it is a worldwide standard now. And OVF packages consist of several files in a directory. So when you have an OVF package for anything that you want to do, it will have many files, not just one file. But there is one file in that directory which has extension OVF. It is an XML file. Everybody knows what is XML, right? So XML file which describes what is in the directory. Okay, it could have an extension VMDK. VMDK is very similar to OVF, so So that is so that will contain all the metadata required to run the package. So your hypervisor will read that file first and then go from there. So VMware, Microsoft, Oracle, Citrix, IBM, and many others support OVF. So that's the universal standard now. That makes life easy. Because all the hypervisors support it. It's not really independent, but all the hypervisors know how to read XML. So 1.1 also allows single VM packages and multiple VM packages. So you could have a multi-VM package too. And other popular formats are VHD and VMDK. All right. Then there is a protocol called PCOIP. This is actually a VMware proprietary protocol for virtual desktops. Basically what it does is, this is for the thin clients. So when you want to do PC and you want to connect over IP, you just want to transport the desktop. So you want to do it in a smart manner so that it doesn't require too much power at the destination, at the thin client. And so what they do is, this is a content aware. So it sends the text and the graphics differently. Text is sent, very easy to send. This doesn't take too much bandwidth. Graphics can take a lot of bandwidth, but what it does is it compresses it. And so server can render it, or it can be rendered at the client. But server rendered means all pixels are rendered at the server, so no codec in the client. Client is very simple. It just flashes it on the screen. Delivery optimization based upon real-time network conditions. So as the network becomes congested, compression gets harder. It's like Skype. Skype knows when the network is congested and it reduces the quality of the voice. Layered rendering. So basically, if you keep on the same screen for a long time, it becomes better. First, it will flash it at the low resolution, and then if it gets more time and nothing changes, your screen will become better. That is called layered rendering. Can be used with or without a hardware PCOIP card. And then they made a card which you can put in your thin client, and that will become much faster. Otherwise, you can run it on as a software as well. But there are other protocols such as RDP from Microsoft, VNC, which is kind of sometimes we use, and X Window System, which is also open source. So there are many similar protocols. I am really surprised that there is no worldwide standard for this, but I may be missing something. Basically, this allows you to send the graphics and the text from the server to your thin client. All right, that brings us to the end of this lecture. And the 5 key points. First of all, virtualization allows computation to be done anywhere, anytime, on any infrastructure. That makes it very easy to schedule and manage resources. And we need to virtualize not only servers, but also storage and networks and everything else. Then we learned that the hypervisor of two types. Type 1, run on the bare metals, and type 2, run on the operating system. This much you should basically memorize right there. Type 1 on the bare metal, type 2 on the host OS. And then the common well-known products are Virtual PC, Zen, ESX, VirtualBox, all those things, right? And then the virtual machines itself comes in a disk file name with extension OVF. OVF is the standard for open virtualization format. Yeah, right. So I think VMDK probably is OVF. I don't know. So the thing is, all of them, Microsoft supports OVF and VMware supports OVF. But they may not, they may have started VHD before OVF, so they may have to just continue using VHD for compatibility reason. But their newer versions, for example, Microsoft Hyper-V, I'm sure supports OVF, and so from there you don't have to do any translation. But for VHD, I think you have to do translation. I mean, there might be something that can read VHD and put it into OVF format. Okay? I mean, there are lots of programs that read VHD that I know. For example, if for some reason something crashes on my computer, I can read VHD. I can go back to VHD disk and take out the file that I need. So there are lots of programs that read VHD. I'm sure there's one program which converts into OVF. All right, so we have acronyms, reading list. Now reading list is all of these books are available to you either by web or by Safari. Okay, so you start reading. Now you don't have to read from beginning to the end. I mean, basically you have to read like any other reading you do. I read all of these, so I put them on the reference list here because I use the material from them. There are lots of Wikipedia links.